Hi, today we're going to be talking about work. This is continuing with chapter 6.4 in your book. Now, work is equal to force times distance. But this equation only holds true if the force is being applied in the direction of the distance. For example, if we have a young boy pushing a shopping cart at Publix, say, and the force is in the same direction as the distance, then work will be equal to force times distance. Just find the force and multiply it by the distance. The problem with this comes, for example, if you have that same shopping cart, and the boy now is not so tall and is applying the force in a direction that's not exactly the same as the distance or the direction that he wants the shopping cart to go. If this is the force, then only this horizontal component of the force vector is actually propelling the cart forward. So if this is a vector, then this is F1 and F2. F1 representing the horizontal component and F2 representing the vertical component. So these two are perpendicular to each other. So if this force vector is F1, F2, then we can do some trigonometry. Cosine of this angle is equal to adjacent over hypotenuse, F1 over F. If I solve this equation for F1 by multiplying both sides by F, I get F1 is equal to F cosine theta. Notice that projected vector, it's called, is the only part of this big force vector that's actually propelling the cart forward. So we'd have to modify this to say the actual formula for work is force times cosine of the angle between the force and the distance, or the direction, times that d. If we take this same picture of this boy pushing this cart, here's a little boy pushing the cart, the big cart, and I say that the boy is pushing upwards at an angle of 72 degrees with the horizontal, and the horizontal is the direction that we want to go. We want to push it down an aisle at Publix 110 feet with a force of 500 pounds. So here the young boy is putting 500 pounds into the cart at this angle and pushing it 110 feet. Well, if I substitute into this formula, then work is equal to 500 pounds times cosine of 72 degrees times 110 feet. And the work done will be 16995.9 foot-pounds. The other option for that would be Newton meters.